Find the integral of 2 over 4 plus 4x squared dx. How do you do that? Let's recall the integral for 1 over 1 plus x squared dx is going to be equal to tangent inverse of x plus constant. So now we can take 4 as a common factor, so it becomes integral for 2 over, let's say 4 common factor, 1 plus x squared dx. We took 4 as a common factor from 4 and 4x squared. So then we can take 2 over 4 outside the integral. It becomes 2 over 4 integral of 1 over 1 plus x squared dx. Now if we match this with the main rule, so you will be getting 2 over 4, which is 1 over 2. Integral for 1 over 1 plus x squared dx is going to be equal to tangent inverse of x plus constant, and that's it. Let's say this example number 1. Let's go for example number 2. Example number 2, it says find the integral of 3 over 16 plus x squared dx. So we can write it as integral of 3 over 4 squared plus x squared dx, and again according to the rule that says integral of 1 over a squared plus x squared dx, we can say that it's equal to 1 over a tangent inverse x over a plus constant. And there's a proof for that, but we're not going to do that in details so that you can do it as easy as possible. So now we can take 3 outside the integral, so you can write it's equal 3 integral 1 over 4 squared plus x squared dx. And now compare them. You can say that 4 is a, and then we can write the answer as 3 over 4, which is the a, tangent inverse of x over a, which is x over 4, plus constant. Let's do another example. Example 3. It says that find the integral of 4 over 25 plus x squared dx. So we can do similarly as we did in the previous question. We can change 25 to be 5 squared. So we can write it as integral of 4 over 5 squared plus x squared dx. So if we take 4 outside the integral, it becomes equal to 4 integral 1 over 5 squared plus x squared dx, which is equal to 4 over, as we said, 5 is considered to be as a, so 4 over 5 tangent inverse x over a, which is x over 5, plus constant. Let me show you something which is more difficult. Let's go for question number 4. So here they are asking you to find integral for 4 over x squared plus 2x plus 5 dx. How do you do that? First of all, let's take x squared plus 2x plus 5 and work with that. We say x squared plus 2x plus 5 is going to be equal. If we use completing the square to make a perfect square here, what do? We look at the number multiplied by x, which is 2, and we divide it by 2, we make it square, and we add it and we subtract it so that it doesn't change the expression. What I mean that, we look at the 2, we say 2, we divide it by 2, we make it square, we add it and we subtract it, 2 over 2 squared. So how does it go here? Let me show you. So it becomes x squared plus 2x plus, what do you get when you have 2 over 2? It becomes 1 squared minus 1 squared, which is the other one. And we have plus 5, we leave it. Now, this becomes x plus 1 squared, so we can write it x plus 1 squared. And here we have minus 1 squared, which is minus 1 plus 5. And finally, it's going to be equal to x plus 1 squared plus 4. And also we can make it as 2 squared. And I will let you know why do we do that. So it becomes x plus 1 squared plus 2 squared. And now we replace it in the integration. It becomes integral 4 over, let's switch between 2 squared and x plus 1 squared. Let's write 2 squared first, plus x plus 1 squared, and here we have dx. And look at the expression now. We can apply the same thing we applied before, so we can say that it's equal, take 4 outside, becomes 4 integral 1 over 2 squared plus x plus 1 squared dx. So we can write the answer is 4 over a, which is 2 tangent inverse x over a, which is, we consider this as x, so this is x plus 1 over a, which is 2 plus constant. This is not x, this is considered to be u, but I'm not going to work with the substitution method here. So if we consider x plus 1 as u and we make du, so it becomes du over 2 squared plus u squared. So it's going to work with u, but as easy as it is, we can write it straightforward, tangent inverse x plus 1 over 2, and we can simplify 4 over 2, you get 2, and this would be the final answer, which is equal to 2 tangent inverse of x plus 1 over 2 plus constant, and that's it. Let's do another question. Number 5. So here we have integral for 3 over 2x squared plus 4x plus 10 dx. How do you do that? Let's take 2x squared plus 4x plus 10 beside, simplify it, and write it in the proper form that we are using inside those integrals. What do we say? We say 2x squared, this is 2x squared plus 4x plus 10. Let's take 2 common factor first. We take 2 common factor, it becomes x squared plus, if we take 2 from here, it becomes 4 divided by 2, which is 2x, plus 10 divided by 2, which is 5. And now we work with this. As we did in the previous example, what did we do? We look at the number multiplied by x, we divide it by 2, we make it square, we add it, and we subtract it from this expression. It becomes equal to, we leave it, open bracket, and here we have x squared plus 2x plus 1 squared minus 1 squared, so as if I did not do anything, and then we have plus 5, close the bracket, and now let's change it to be in the proper form. It becomes equals to 2 bracket. Now here x squared plus 2x plus 1, it is a binomial square, which is x plus 1 squared, minus 1 squared, which is minus 1, plus 5, which is plus 4, so it becomes plus 2 squared, and now we replace it in the integral. So we write integral 3 over 2 into x plus 1 squared plus 2 squared dx. Let's take 3 over 2 outside the integral. It becomes equal to 3 over 2 integral 1 over. We switch between 2 squared and x plus 1 squared. It becomes 2 squared plus x plus 1 squared dx. And we apply the same thing we did in the previous question. We say equals, this is 3 over. Here we have 2, and we have another 2, which is the a. So we multiply it by 2, it becomes 4. Let's write this straightforward. 4 tangent inverse inside, which is u, or we write it as x plus 1 over a, which is 2 plus constant, and that's the final answer. Let's have another question. We have integral 1 over radical minus x squared plus 6x minus 5 dx. How do you do that? So we can write minus x squared plus 6x minus 5. It's equal to, let's take minus as a common factor. We open bracket, we write x squared minus 6x plus 5. We switch all the signs here, right? Then we can write equal, minus, we keep it outside, open big bracket, because we're going to arrange for a binomial square. So we write x squared minus 6x, and then we divide 6 by 2, we make it square, we add it, and we subtract it. So we say 6 divided by 2, which is 3, 3 squared, it becomes plus 3 squared minus 3 squared, and then we have plus 5, we leave it, and then we have it equal to minus outside into x squared minus 6x plus 3 squared, it is x minus 3 all squared. We take x, we take 3, and we take the minus sign, and it gives us x minus 3 squared. And here we have minus 3 squared, which is minus 9, plus 5, which is minus 4, so we write minus 4, we close it. Also we can write it's equal to minus into x minus 3 squared minus 2 squared. Close the bracket. And here, because of the minus, we can switch between those and remove the minus. It becomes equal 2 squared minus x minus 3 squared. What I did here, I switched between x minus 3 squared and 2 squared, and I removed the minus outside, so it becomes 2 squared minus x minus 3 squared. Now replace it in the integral. It becomes integral of 1 over radical 2 squared minus x minus 3 squared dx, which is equal to, if you go back to the rules, you can find that 1 over radical a squared minus x squared is going to be equal to sine inverse of x minus 3 over 2 plus constant. You should memorize those rules so that you can find the answer straightforward. This is all for now, and keep following because we will be talking about integration by parts and volume of revolution in the coming videos. Thanks for watching.